Okay, this video I want to talk about second activity to support kids to build the algebraic concept in young age. Oftentimes we think algebra in the middle school thing, but that's not true. We can build algebraic understanding when they are young. So that's why I want to introduce this activity. So first one we did in the earlier video was equal sign, introduce meaningful way the equal sign means. So if we introduce equal sign as balance, both sides are the same, that's a correct concept. If we introduce equal sign as answer comes next, that might mislead the kids' understanding of equal sign at the later grade. So how to introduce equal sign and the true meaning of equal sign is very important. So second video, this one we'll talk about connect arithmetic with algebra using switching a number from to symbol. That's what we are going to do. So you are going to need these two handouts from the canvas. So one of them is block pound and the other one is balancing act. So both of them are available from Canvas. So I want you to download this before starting it. If you haven't downloaded this or print out, please do so to easily follow the video you are going to watch. Okay, so if you look at the first, we're going to talk about the block pound first. You have the problem A, B, C, D, and it says that a scale A says cube plus cylinder is 14 pounds. Scale B says a cube is 5 pounds. Given this information, I need to find out how much does cube weigh and how much does a cylinder weigh. That's what we are trying to find out. Same in here. For problem B, we have scale A, cylinder plus sphere is 18 pounds, and 2 cylinders is 16 pounds. And using this information, how can I find out the sphere and weight of sphere and a cylinder? That's what we are going to do. And while we are doing this, think about what grade level is this maybe appropriate problem. So we are talking about one digit plus addition and subtraction probably. And think about what grade level this is appropriate. Let's do the A first. So it says, I'm going to show you some manipulatives. So it says, this is A, a cube plus a cylinder is 14 and a cube is 5. Given this information, can you find out the weight of cube and a cylinder? This is given, so I know that this is 5. Then how can you find out this weight of a cylinder? I know that this is 5, so I know that 5 plus cylinder is 14. So a cylinder is what? 14 minus 5, which is 9. So you see how I did it? So I can easily find out, plug in this number in here, and then I do the subtraction to find out my answer. Okay? So that's A. What about B? B says a cylinder plus sphere is what? 18. That's scale A. Scale B says 2 cylinders equals 16. So given this information, can I find out how much does sphere weight and how much a cylinder weight? Can you think about it for a second? So how can I find that? Do you want to go for this one first or that one first? Maybe I want to start from here because I know that 2 cylinder makes 16. So probably 1 cylinder should be 8. How do I know? 16 divided by 2 is 8. So I know that this is 8. Once I figure that this is 8, how can I find out the sphere? The sphere is going to be, because going to be 18 minus 8, which is 10. So a sphere is going to weigh 10. Is it right? Good. Something like this. You can try use this one, and then what do you think about grade level maybe kids can solve? Probably it's not very upper grade level, probably I don't know, first and second grade should be able to do it. What about C? Let's do C, and I'll give you D, so you can solve them if you want to. So I'm gonna do sphere plus cylinder is 7, and a sphere is 3, and a cube plus sphere equals 12. Using this information, can you find out the weights of cube, cylinder, and sphere? Why not? I can do it. I think I can do it, right? Okay. So this is 3. So I can plug this number into here. Then 3 plus cylinder is 7. Then what is my cylinder weight? So I'm going to subtract 3 for both sides. So my cylinder is going to be 4. Right? What about, so I know that sphere is, this is 4 and sphere is 3. Then I need to find out, the last one is this. So I know that this is 3 from here. So this plus 3 equals 12. And how can I find out this? I'm going to take away 3 for both sides. So it's going to be 9. So I know that a cube weighs 9. Does it make sense? We all know that this is 9 and cylinder is 4 and a cube is 3. Okay? So now I want to connect these two symbols like x, y, and z, a, b, c. We use letters for algebraic equation. So that's why algebra comes from the letter, because we want to generalize a rule. But conceptually, algebra and arithmetic are pretty similar. But for the arithmetic, we're using numbers like this. But the algebra, we use letters. That's the only difference. Conceptually very similar. But oftentimes we don't practice switching a number to symbols. Kids all of a sudden think, oh, algebra is a middle school thing. I have no idea how to find the number. No, that's not true. I'll show you how easy it is. So let's go back to the first one again. And we are going to rewrite all the sentences here. So I'm going to ask you to think about this is x. And cylinder is y. And then sphere is going to be z. So I have letters I want to use for the equation. Let's go back to A. So it was a cube plus cylinder was 14 and a cube was 5 pounds. So I want to rewrite the equation using letters. So it's from here, this is x. X, this is y. Plus y equals 14. And what's this? But now I know that my x is 5. Right? So I'm going to plug in 5 here. Then what do I need to do? We need to subtract x, which is 5 on both sides. That's the key concept of algebra. We talked about this in the earlier video, equal sign here. If we do things in one side, we have to do the same thing for the other side. Right? So I have 5 plus y equals 14. I'm going to take away 5 on both sides. My y is going to be 9. So this is typical algebra, linear equation, right? X plus y and z, those things that we are doing for beginning algebra. This is what we are doing. It's very exactly the same thing in here. We just don't talk about that the symbols as young as possible, but the conceptual, this is what we are doing. If they are doing this with numbers, why not doing with the letters? So this is something you can try to connect the numbers to symbolism. That's the beginning concept for the algebra. So the kids they don't need to be afraid of knowing a number. So a lot of people, I heard from them saying that, I give up my mathematics when I see the letters in the equation. Is that true? No, that's heartbreaking because they can still do it using symbols. This is a kind of foundation for them to think about what's the algebra. We use letters to generalize the rule, right? So this is something they can easily try. So without knowing the symbol, when you're talking about this for second grade activity, you can try for second grade activity using letters. If we have manipulatives like I do, I'm pretty sure kids are going to do it. Let's do one more, B, and I'm going to move on to next one. So B, so the scale says cylinder plus sphere is 18. 2 sphere is 16. From this up here, the equation, the symbolism in here, I want to plug in, I want to rewrite the equation using this. So what is it then here? This is y plus z equals 18. And this one is 2y equals 16. Then what do we do next? I'm going to divide this number by 2 to find out my y. My y is 18. This is 18. Sorry, this is 8, not 18. So this is 8. And my y is 8. Then can I find out this on my z? Because if this is 8, right? I can take away 8 for both sides. That's the algebraic concept. If we do something in here, we have to do the other side too. So my z equals 10. So this is 10. Right? So this is the beginning algebra concept. We don't need to think about, algebra is a middle school thing, I don't know how to do that. No, this is very simple basic algebra. So kids need to be familiar with using letters in the equation. It's okay to have a letter in the equation. They need to see them as early as possible. That's going to be a foundation for kids to understand the algebra. Okay, let's move to balancing act. So if you don't have the paper with you, please print out or pull up on your screen so you can follow what we are doing. So balancing act. So we're going to do A, B, C here. Let's look at the A one here. There's no numbers in here. They only have pictures. But you can still find out here. So I have a scale A. It says sphere plus cylinder, same as balanced as 4 sphere. And I want to there are 2 cylinders in here, and I want to make my sphere and my scale balanced. And how many spheres do I need to have? How can I find out that? Using pictures. When you see the pictures in here, this plus this and the 4 sphere. So I want to know how many spheres do I need to have for 1 cylinder. Can I do that? How can I do that? So I'm going to take away 1 sphere from each side, both sides. Remember, to remain balanced, we have to do the same action in both sides, right? Then you can find out 1 cylinder the same as 3 spheres. So then 2 cylinders, then how many spheres? Yes, 1, 2, 3, 4, 5, 6. Right? Good, that's easy. What about B? B says 2, scale B here, 2 cylinders, same as 6 spheres, and I have 9 spheres in this side. Then how many cylinders do I need to have? If I have 9 spheres on one side, then how many should I have here? 3. Right? So they can do easily here with manipulatives. I have to be balanced. It has to be balanced. Right? Good. What about the last one? Last one says which one, they don't give the number, but last one asks you which one is the heaviest and which one is the lightest? Do you think you can find out? Let's do it. See, it says this one, same as and then the other one says 3 sphere, same as 1 cylinder. Right? So, and they ask, look at the pictures there. Which one is the heaviest? Or which one is the lightest? How do you know? So think about that. This one needs 3 spheres. So I think this is the heaviest. We have the same unit, but my cube needs 2 spheres. So this is the second, and maybe this is the lightest. So kids can see that. Or I can assign the value. Suppose that one circle weighs 1 pound, and I have 2 here. So my cube weighs 2 pounds, and I have a 1, 1, 1. So my cylinder is 3 pounds. So this is the heaviest, and this is why. How should I know? Okay, good. So same thing, we're going to do the same thing. So the earlier balance block pound, we plug in this symbol, pictures, shapes with symbols. Let's do the same thing so it makes sense to you. So this is conceptually algebra. We just don't talk about this as algebra, or we don't use symbols, but this is algebra. Let's do the 8 again. Okay. So this is a sphere plus a cylinder, same as 4 spheres. And then I want to plug in this with letters there. So this is Z, and this is Y. This is 4Z. They're the same. This is algebra. We want to find out algebra problem in here. And I want to know what my Y is, and what do we do? In equation, if we want to leave Y alone, what do? We subtract Z from both sides, so that's cancelled out. So Y equals 3Z. This is what we are doing for algebra. This is what we are doing. We eliminate Z from each side. So I easily find the Y, same as 3G. That's what we are doing. We just don't see the connection, but this is what we are doing algebraically. Right? Good. Let's do B. I'm going to show you B, and then we're going to stop for this activity. Okay? Okay, B. So I have 2 cylinders, the same as how many spheres? 6. 1, 2, 3, 4, 5, 6. Z. So I'm gonna rewrite this one as 2Y, same as 6Z. This is what we have from here, right? And I want to find out my Y is. What do we do in algebra? We do divide this number by 2 for both sides. So I know that Y equals 3. Right? And then second scale in here, they want to figure it out. If I have 9Z, how many Y? That's what we need to figure it out. This is algebra, right? But from here, we know that Y is 3Z. So this is 9Z, that means we need 3Y. Right? So I'm going to add 3Y. Oops. 3Y equals 9Z. This is what we are doing. Do you see the connection in here? Right? So this is algebraic concept. This is what we are doing here. We want to find out this multiply 3 here. 3 times 3 is 9, so it has to be times 3 too. So it's going to be 3y. So when you think about the concept of algebra and equation, it seems very difficult. But using symbols and pictures, it's easy. That's why the visual representation is important when you introduce something, some concept to the kids. So kids can do it conceptually, and then you can provide the abstract way to show them. It's always start from concrete concept, and then you can move to abstract concept. Okay, good. So if you have any questions about this, please let me know. And this is all about the balancing act and symbolism activity here. Thank you for watching.